So, what if I told you that you and me and literally everyone else on this planet are part of a massive, unplanned scientific experiment? That is the absolutely wild and powerful idea at the heart of geologist William W. Hayes' book, Experimenting on a Small Planet. And today, we're going to break down how scientists even realized this experiment was happening and, what the results might actually mean for all of us. So, where does a story like this even begin? Well, it doesn't start in a pristine laboratory. It starts at a tense dinner table, right in the middle of the Cold War. Okay, so picture this. The year is 1982. The Cold War is at its peak, and the Reagan administration is worried. They've heard whispers that the Soviets might be developing some kind of weather weapon. So they dispatch a small team of American scientists to Leningrad to, discreetly figure out what the Russians really know about the climate. On the American side, we have our author, the geologist William Hay, and his Soviet counterpart, none other than Mikhail Budiko, the most respected, most distinguished climate scientist in the entire USSR. This is a guy whose work had already convinced the Soviet government to scrap a gigantic plan to divert rivers in Siberia, so he's a heavy hitter. As Hayes walking back through this historic city, he just can't shake what they've been talking about. He's looking around Leningrad, a city built barely above sea level, and it all starts to click. So he turns to Budiko and asks him a really pointed question. Basically, could the Arctic sea ice really melt if we don't get a handle on CO2 emissions? And Budiko's answer was just chilling. He didn't say maybe or it's possible. He looked Hay right in the eye and laid it out as a certainty, an inevitability. It's going to happen. The real question then, the one that must have kept Hay up all night, is this. What on earth did Budiko know way back in 1982 that made him so incredibly sure? To understand that certainty, we have to learn how to do what scientists like Budiko did. We have to learn how to read our planet's own diary, a story written in layers of rock, in ancient ice, and in the oceans themselves, stretching back millions and millions of years. Now, this wasn't some overnight discovery. It was a puzzle pieced together over centuries. It really started in the late 1700s, when geologists just began to grasp that the Earth was mind-bogglingly old. Then, fast forward to 1896, and a scientist named Svante Arrhenius makes the first real connection between CO2 and temperature. Then things accelerate. In 1957, scientists sound the alarm, first coining that phrase a great uncontrolled experiment. And just 1 year later, Charles Keeling starts taking the daily measurements that would give us the hard data. And all this research revealed something pretty startling. The world we think of as normal is actually the weird, rare state for our planet. You see, for about 3/4 of its entire history, Earth was a greenhouse planet. That means no ice at the poles. At all. We're currently in a much cooler icehouse state, and even now, we're just in a short, warm little pocket called an interglacial. Okay, so what's causing these massive, planet-wide shifts from greenhouse to icehouse and back again? Well, for millions of years, long before we showed up, the climate was basically run by these huge, natural, almost clock-like rhythms of the planet itself. They're called the Milankovitch cycles. And in a nutshell, they're just 3 long-term changes in how the Earth moves through space. You've got the shape of its orbit, the tilt of its axis, and a little wobble. And all together, they act like a planetary pacemaker, changing how much sunlight hits different parts of the Earth, which is what kicks off the ice ages. And what's so cool is that this isn't just some abstract astronomical theory. It's real. You can literally go see it. Geologists can read the rhythm of these cycles written directly into ancient rock layers, just like these. It's a physical diary of climate change, driven by Earth's long journey around the sun. The second major driver is a concept with a kind of funny name, albedo. But it's actually super simple. All it means is how reflective the planet is. That's it. Think about it. Bright, shiny surfaces, like snow or ice, or even this amazing cloud of tiny phytoplankton, they act like a mirror, bouncing sunlight and its heat right back out into space. They help cool the planet. But dark surfaces, like the deep blue ocean, they just soak that heat right up. And this creates a really powerful feedback loop. As ice melts, it reveals the dark ocean underneath, which absorbs more heat, which melts even more ice. See how that works? All right, so we've got the planet's orbital wobble and its surface reflectivity. The third and maybe most important driver isn't in space or on the ground. It's right there in the air all around us. So the huge majority of the air we breathe, mostly oxygen and nitrogen, is basically invisible to the heat that radiates off the Earth's surface. Heat passes right through it. But other, more complex molecules, especially water vapor and carbon dioxide, they act differently. They catch that outgoing heat and they radiate it back down, basically wrapping our planet in an invisible warming blanket. And let me tell you, that blanket is absolutely crucial. Without this natural greenhouse effect, the average temperature on Earth would be a frigid -18 degrees Celsius. That's about 0 degrees Fahrenheit. We'd be a ball of ice. So the blanket itself isn't the problem. The problem is we just keep making it thicker and thicker. So now we can finally bring all these pieces together, the orbital cycles, the albedo effect, and this atmospheric blanket, to really get our heads around the book's central, powerful idea. William Hay has a specific word for it. He doesn't call it terraforming, which is when you change another planet to be like Earth. He calls it anthropoforming. We are reshaping the fundamental systems of our own planet, and we're doing it at a speed that is just unheard of in geologic time. And this book cover, man, it just perfectly nails the whole idea, doesn't it? The Earth itself is in the beaker. All the exhaust from our cars, the smoke from our factories, those are the chemicals we keep pouring in. And the burning of all those fossil fuels, well, that's the Bunsen burner we've lit right underneath our own home. So, what are the results of this massive experiment? As it turns out, it's a lot more complicated than just things getting a little bit warmer everywhere. And you know what's wild? Here's another quote from 1982. The same year as that Leningrad dinner. A climatologist named Hermann Flohn predicted that the very first sign wouldn't be a gentle warming trend. It would be instability, extremes, weather going haywire and setting all kinds of local records. Basically, chaos. Which is exactly why, years later, the columnist Tom Friedman suggested we should call it global weirding. And that term really captures it, doesn't it? It's not just about record heat waves, but also record cold snaps. It's about epic floods and crippling droughts. The whole system is just getting less predictable and way more extreme. And this brings us right back to that dinner in Leningrad and to Mikhail Budiko's stark warning. His certainty wasn't just a guess. It was based on his deep understanding of these fundamental forces, the planet's orbit, its reflectivity, and the basic physics of our atmosphere. And today, we know he was right. The Arctic sea ice is disappearing, and it's happening even faster than he thought it would. I think we should just let that final haunting thought from William Hay sink in for a moment. The grand, uncontrolled experiment is well underway. There's no control group, there's no other planet to try this on. We are all living inside the lab, and we're all, together, waiting to see the final results.